Rice University's entry into the 2009 Solar Decathlon competition, which is going to be held in Washington, D.C. in October. Right now we're in Houston, Texas during the final stages of construction, and I just want to tell you a little bit about our house. The Zero House is named for being a zero energy row house. And what a row house is it's a shotgun style house that's very typical to communities in the South and in Texas. And in Houston we have a particular community in the 3rd ward of the city, and it's called Project Row Houses. And what Project Row Houses does is start to renovate and revitalize the community in the 3rd ward, and also provide artists with an area for living and working, and it's a really great community. And so what we're doing with the Zero House was designing it to actually go and be a part of Project Row Houses after we compete in the decathlon competition. So when we bring the house back in November, we'll be installing it at row houses to become a home for a low-income family.
So for the design of the house, we looked into the 3rd ward shotgun house typology, and we wanted to try to modernize that housing model.
The traditional shotgun house is typically an elongated box, and the front is the most public space and the back is the most private. So if you can imagine taking the living room, the dining, the kitchen, having that towards the front of the house, and then it ends up with the bedroom at the end. And they're typically situated in such a way that you can circulate straight through all of them, so they're all connected inside the envelope.
So for the design of the Zero House, we wanted to imagine this box as an empty envelope, and we wanted to insert in 2 solid volumes, one being the light core and the other being the wet core. And these 2 cores begin to separate the space from the public end to the private end, providing a transition between the 2.
By inserting these 2 volumes, we keep to the existing typology program, but by inserting the light core, you only visually are connected from the front of the house to the back of the house, whereas traditionally in the row house you can just circulate straight through. But our house is a bit unique with the light core. You actually have to move around the light core once you're walking through the house. And same with the wet core, it's an inserted volume, so you have to move around the wet core of the house to the bedroom, keeping it a bit more private than the existing typology.
And for the exterior house, we choose to go with the corrugated siding, only because I think we look into the Texas vernacular architecture, how these old barns are using metal roofs and metal siding, and we want to keep it that idea of this Texas vernacular. That's why I think corrugated metal was the right choice for the house.
Yeah, it also is a great component of sustainability because the owner, which will live here after the competition, will not have a hassle of trying to paint their house. It's very low maintenance, and it's also something that kind of adds to the existing neighborhood. It looks different, so it's a bit more modern, using something metal as opposed to the traditional wood.
So the Zero House features a photovoltaic array of 24 solar panels. You can see 8 of them right over here. Altogether they produce 4,200 watts of solar electricity. And each of these panels right here produces DC electricity, about 175 watts per panel. And unfortunately DC power isn't what we can use inside the house. So each of these panels has behind it 1 microinverter that converts the DC electricity from the panel into AC electricity that the house can use. And all those microinverters are strung together and they feed back into our house. And over the course of the year, the electricity that those panels are producing would be more than enough to run this house. So the Zero is what we call a grid tie solar home. And what that means is that we're staying connected to the normal electric grid, that you normally pay your electric bills to. And then we've got our solar array right here. And when we're producing more electricity than we use during the sunny days, we send that electricity back into the electric grid and we get credited for it. And then at night when it's cloudy, we take electricity from that electric grid. And over the course of the year, the energy that we send in and the energy that we take out of the grid will be net zero. And that's why we call it Zero, the Zero Energy Row House. And this is the mechanical closet of the Zero House. Now, most of what we have here is our solar hot water system. So the way this works is that we've got a big 80-gallon storage tank right here. Basically, this is just a big thermos, just a very well insulated tank. Cold water from the city comes on into the bottom of the tank, and then water is pulled out of this tank, pumped up by this pump to the solar collectors on the roof, and then pumped back down here quite a bit hotter. Now the way the collectors on the roof work, we have an evacuated tube solar collector system. And what that is that we have an array of 30 evacuated tubes, or glass tubes with a little heat pipe inside it. And the heat pipe collects all the warmth of the sun that's falling onto those tubes and transfers it to the water that flows through the black header at the top of the solar collector. And that water goes through and will heat up. We'll get temperatures as high as 200 degrees Fahrenheit. That water flows back down into the tank, and we get a very warm batch of water here. And once this tank is full, it'll only lose 1 degree Fahrenheit of heat every hour. So there'll be plenty of water by the time you wake up for your morning shower the next day. And our water flows out here for service to the rest of the house and off to where you're going to take a shower. But before it goes to the actual faucets, it flows through this, which is our electric tankless water heater. And this guy senses the temperature of the water coming into the heater, and if it's a little cool, it heats it up just to the point where we need it. But if the water's already at the temperature we want it, it's not going to do anything. So most of the time, this solar heater is going to be producing all the heat we need, and the heater's just going to be sitting there. But if we have clouds for 5 days in a row, this guy will be able to kick in as our backup.
Working with the engineer a year ago, it seemed like the best way to make a transportable rigid box was to make a rigid frame underneath it. So basically there's a welded steel tube chassis that keeps the whole thing rigid. That then allowed us to do very conventional systems above that. And we did conventional systems for two reasons. One is they're conventional in Houston, they're common, they're inexpensive. And secondly, the students are able to work with these systems. It's easier, I mean, we had a debate about using steel studs versus wood studs, but it's a lot easier to work with wood studs, especially for people who are not familiar with it. One of the things that's made the wood frame system so strong is the use of the plywood diaphragm on the outside of it. And in effect, you could probably make a completely rigid box just by gluing and screwing plywood on like we did. So even though we have the rigid steel chassis, we also have completely rigid, I won't say completely rigid, but fairly rigid diaphragm walls above that. One other aspect that is not immediately apparent is there are transverse shear walls that are bolted down to the frame, so that not only are we strong in this direction, but we're also strong transversely. The stud wall system is conducive to the use of the Isonine insulation, which is a very efficient insulation.